Okay, guys, I want to give you an example of number one before, because we didn't get to this last example. So I'm going to do a couple examples before you get into this. If I say from yesterday, the integral from 5 to, let's say, e to the x of, I don't know, I want the derivative. The derivative of the integral from 5 to e to the x of whatever it is. Let's call it c of t dt. Right? What do you do? I mean, there's ways around this, but what do you do? You could, but you don't need to. What do you do? The derivative of the integral cancel each other out. The only thing you have to be careful of is that you do the chain rule. So it would be c of e to the x times the derivative of e to the x. So that's the chain rule. And then that's your answer. Now, the reason that's your answer is because the bottom is a what? Constant. Okay? If I give you another example where it says d dx of the integral from, let's say, 2x to x cubed, I don't want to use the same one, of c of t dt. Let's go about it the long way because we didn't do an example like this. First thing you would do is take the antiderivative, right? Yes. So what would you call the antiderivative of c? Capital C. Okay, so capital C of t evaluated from 2x to x cubed. And then after we're done with that, we're going to do the derivative. So this is going to be capital C of x cubed minus capital C of 2x. And then the derivative. So what's the derivative of c? Lowercase c of x cubed times 3x squared minus lowercase c of 2x times 2. So what's the difference between this and this? Right. In this one, when I did the antiderivative, I got some constant value, right? And then when I took the derivative of the constant, it became 0. So that's why we don't have this minus anything here. So here, it's the same thing. What do? We took the function. The final answer is what? What do? You plug in the upper bound to the function. And then what? Chain rule, so multiply it by 3x squared. And then minus, plug in the lower bound to the function times its derivative. Does that make sense? Okay, so give that a shot, go. Okay. All right, number one. Simplify the following. We are taking the derivative of the integral. What happens to the derivative of the integral? They cancel each other out. Now, we could go about it the long way and actually take the integral and then take the derivative, but we have a problem. We can't take the integral. Do you guys know the integral or the antiderivative of tangent of rad t? No. So we can't go about it by taking the integral and then taking the derivative. I think I gave you that example yesterday, but something like this. If I were to say the square root of 11 squared, if you really want to understand what's happening here, what would you have to do? You'd have to take the square root of 11 and then square it, right? But do you know the square root of 11? No. But to get the final answer, you don't need to, because what happens? They cancel out and you're left with 11. It's kind of the same thing here, but you have to be careful. What's the rule say from yesterday? What's the fundamental theorem of calculus part 1 say? It says the derivative of an integral where the lower bound is a constant and the upper bound is the variable of the integrand, whatever, is equal to just the integrand, right? So we don't know the integral of tangent of rad t. So let's just assume that we know it and call it something. What do you want to call it? Call it f. So we would say capital F of t is what? Equals the antiderivative of tan rad t. So how do I evaluate this part? Capital F of t evaluated from x squared to 3x. So what is capital F evaluated from 3x to, or x squared to 3x. F of 3x. Okay, and then what do I, that is just the what? That's just the integral. I have to take the derivative, right? So I have to take the derivative of all this. So what is the derivative of f? Okay, I want to make another connection here, and I forgot to write it down here. If f is the antiderivative, then f prime, what did I do to that side? Took the derivative, so I got to take the derivative of this side. So what happens when I take the derivative of the antiderivative? I get the function, so what do I get? Tangent of rad t. You guys okay with that? So now, what is the derivative of capital F? What do we call it? F prime of 3x, but I have to use the chain rule, so times 3, minus f prime of x squared times 2x. Okay. Now, what is f prime of 3x? Well, f prime of t is tangent of rad t, so f prime of 3x is what? Tangent of rad 3x minus 2x times tangent of rad x squared. You guys okay with that? Yeah.
For the tangent x squared, can you would it be allowed to just be x?
Yeah, that's fine. That's fine. So that could be just x simplified. Number 2, how do you find the average value? Average value is equal to 1 over b minus a. So in this case, 1 over pi minus 0. The integral from 0 to pi of sine of x dx. So let's figure that out. That's going to be 1 over pi times, what's the integral of sine of x? Negative cosine of x evaluated from 0 to pi. So we would say negative cosine of pi minus negative cosine of 0. And then the 1 over pi is just all over pi, right? What's negative cosine of pi? Well, cosine of pi is negative 1, so negative of that is 1. Minus, what's cosine of 0? 1, so we have a negative 1 there. So we end up with 2 over pi. That is the average value. Now, just to compare that to another question I could ask, with the same function, if y equals sine of x, I could ask for the average value, but I could also ask for, what else could I ask for in terms of average? We don't know? Average what? Area? No. Average rate. How would you find average rate? What does derivative give us? But it gives us what kind of rate? Instantaneous rate. I want the average rates. So what is derivative in and of itself? What does it mean? You're finding what? The slope. So what is average rate? It's a slope. It's a slope over that interval. So what would I plug in? It'd be sine of pi minus sine of 0 over pi minus 0. Right? That's just the slope. So it'd be 0 minus 0 over pi, or 0. My point is, be very careful about what I ask for. Because a lot of you will think average rate when I say average value, or vice versa. And you'll set something up that doesn't make sense.